Now in this lecture, we shall be discussing about the structural steel connection components first of all. So before we study about the bolted connections, or we can say welded connection, we should first of all, we do need to understand what exactly are the different type of bolts that are available in Australia. What exactly are the different type of welds that are done in Australia. After that, what are the, we can say, parameters that govern the design of the, we can say, bolts and weld itself. So first of all, we should be studying about the bolts. Then we should be discussing about the welding, we can say welds. And then after that, we shall be, we can say, discussing about the connection as a whole itself, and which may have a bolting also and welding also. So primarily we can say, when we want to join the two components at the construction site itself, in that case, we shall do the bolting at the construction site. But if we are at the workshop, so at the workshop where we are fabricating the different steel structure, and at that particular place, we do have full control over the welding component. We can do, we can say, different types of, we can say, welding, which is, we can say, much in superior in parameters as compared to when we do the similar welding at the site. So that is why, primarily the welding is done in the workshop itself, but when we are at the construction site, majority of the bolted connections are only used. So after that, if we are talking about the connection, the structural steel connections, so the simple thumb rule here is that, let us say, our the total tonnage of the building that we are dealing with is, let us say, 100,000 kg. So in that case, the simple thumb rule is that the connection weight should be 15 to 18% of the total structural steel weight. So we can say that approximately 15,000 to 18,000 kg shall be the weight of the, we can say, connection. So in that connection weight, we may have plates also that shall be, we can say, bolted to the column flange. That shall include the weight of the bolts also. That shall include the weight of, we can say, gussets also. So all of those components to account, we can say, approximately 15 to 18% of the total tonnage of the structural steel. And this is the simple thumb rule that is, usually correct in most of the cases. So in New Zealand, where the earthquake is very, a governing parameter, and the connections that are designed, that has to be, we can say, seismic resistant connections. So in that case, this, component may go as high as 20% to 20, we can say, 22% also. So that is like the, we can say, simple thumb rule that I do follow in my practice. So after that, if we are talking about the different types of connection, first of all, so primarily we had discussed about the shear connections and moment connections. So we won't be, repeating that exercise again. But first of all, I just want to, explain you in detail, first of all, regarding the bolt as a component itself. What exactly are the, different parameters of bolt that are usually used in Australia? So bolt as a component should be clear to you before we start doing the actual, we can say, structural steel component or connection design. One option is that class 4.6. So class 4.6 bolts are the bolts that are, like, we can say, temporary bolts only. They are usually of the low carbon steel, and we can say that their behavior is more or less equal to the grade 250 steel. The grade 250 structural steel that we use, the yield strength of, these bolt and grade 250 steel is more or less same. So 4.6 means that, the tensile strength of the material that is made, for this particular bolt, that is approximately, we can say, 600 Newton per mm square, or MPa. After that, if we want to calculate the yield strength, of this particular 4.6 grade means what we need to do is that we need to multiply 0.4, this 4 that shall be 0.4 multiplied with 6, that is 600. So yield strength of this particular 4.6 grade bolt is 240 Newton per mm square. So that is the way with which we can always remember what exactly is the yield strength of class 4.6 bolt. So 4 gets converted into 0.4 and 6 gets converted into 600. Multiply them and you shall have your, we can say, yield strength. After that, the second parameter is the, we can say, class 8.8 bolts. Now these are the bolts that are used in the structural steel connections. Whenever we have to make a building or a structure with we can say strong connections, and that is a permanent structure, in that case we always follow class 8.8 bolts. These are known as the, we can say, connection bolts, and we can say they are high strength structural bolts. I mean, if you do have a project and if you are going to the site, just first of all ensure that whatever bolts are being used at the site, they have to be class 8.8 bolts only. The code that is governing their design is basically AS NZS 1252, and we can say that they are made of medium carbon steel. Medium carbon steel, and basically we do they are made using the quenching and tempering to achieve the enhanced properties. So they may be sensitive to the high in heat inputs. Let us say we never weld them, or we never use them where we have to be having the, we can say, high heating parameters. So class 8.8 bolts, we do understand the high strength structural bolts, medium carbon steel, and the same thumb rule that we used here, same thumb rule we can use here also. So tensile strength, we can say tensile strength of these bolts is approximately, we can say, 800. So this 8 that comes here, so 800 Newton per mm square, and we can say yield strength, that is approximately, we can say, 0.8 into 800. So yield strength of these bolts is approximately, we can say, 640 Newton per mm square or MPa. So similar to class 8.8, we do have 10.9 grade, we can say, bolts also. So if you're talking about the, we can say, 10.9, we do have similarly 12.9 grade bolts also. So these are, we can say, extremely high strength bolt, but at the same time they are, we can say, a little bit of, we can say, brittle, and they show less ductility also as compared to the class 8.8 bolts. To be used only in the special parameters under the specialist advice only. Like everyone is confident about the class 8.8 bolts, but no one is much confident about the 10.9 grade because of the the brittle behavior, because of the, we can say, extremely high strength do comes at a cost. So the cost is lesser ductility and the lesser, we can say, deformation, and we can say non-linear behavior under the stressed conditions. So it is never recommended to use the 10.9 or 12.9 grade bolts just like that. So after that, as I said that if we want to talk about the 4.6 grade, so we have studied about the 4.6, we have studied about the 8.8, and we have studied about the 10.9 or 12.9. So when we're talking about the 4.6 grade, they are as I said, they are usually snug tight at the site. This is a term that we shall be discussing very shortly, but just to start, let us assume that 4.6 shall be snug tight. After that, when you're talking about the 8.8 bolts, they may be, we can say, tensioned also. So there may be, we can say, type bearing or type friction, that is TB or TF. That also I shall be explaining to you shortly. So we can say that they can be, we can say, snug tight also, but it is always recommended to use class 8.8 grade bolts under the TB or TF, so to fully utilize the capacity of that. So that is the, we can say, introduction. to the different types of bolt. So when we're talking about the snug tight, and when we are talking about the TB or TF, what exactly is meant by the different, the terms that we are using here? Just to give you, I just want to ask you a question. Let us say you do have a column and you do have a girder on which you want to join with the help of the bolt. So you do have some holes here, and separately you are provided with, we can say, for so let us say 8.8 grade bolts. So let us say this is how the bolt looks, and we do have a nut also. So let us say this is the bolt and this is the nut that shall be fitted on the top of that. So how we shall be using that, and there is a washer also. So there are different options. One option is that you can use the typical wrench, that is usually available. So that wrench, we can use, and we can simply, fix this particular beam to this particular column here, and matching the holes, we can just simply put our bolt inside, put our nut, and tighten that with the help of this particular wrench. This procedure that we just highlighted here, that is known as the, we can say, snug tight parameter. This is known as snug tight, where a healthy person tighten the bolts with the help of the wrench. That is known as the snug tight bolt. Second option here is that, when we are using these kind of, we can say, parameters, second option is that we can apply or consider the usage of the torquing, or we can say wrench torque. That is known as the torque wrench, sorry. So let me just show you the actual photos on the internet. So this is the standard, we can say, digital torque wrench, which allows us to, tighten the bolt, and which allow us to pre-inbuilt some, we can say, a particular tension inside the bolt, so that it gets, the locked correctly, or we can say in a much superior manner as compared to the manual wrench tightening. So that is the digital torque wrench. So that we have understood. After that, again, if when we are talking about the TB, that is bearing type, or we are talking about the type friction. So in that case, there are cases where, the connection itself, that is the connection, that can be a little bit, we can say, flexible. That is, a little bit of moment shall be there between the, we can say, bolts, between the nut and the component that is being tightened. The other case, friction type. In friction type, basically locking happens. That is, locking happens between the bolt and the plate itself. That is a connection plate, the one that we are seeing here. So basically the tightening between the bolt and the nut, that is being happened with the help of the friction here. So that is why it offers much superior performance as compared to this particular case, where we are simply using the bearing, or the, we can say, bolts on the plate. So that is why, it is being classified into two different cases, that is type bearing and type friction, in which the type friction is much superior as compared to the type bearing. It is not that, bearing type bolts are not used. Bearing type bolts are also used. Friction type of bolts are also used. But the only difference is that when you are designing the connection, you should be, confident about which are the bolts that you're using, and what exactly are the, parameter that are being considered. First of all, we have studied about the snug tight. Then these are the bearing type, that is TB. Then it is a friction type, that is the, the most superior performance of the bolt. And this is the least, we can say, type of bolt that we can say that are used in the structural steel connections.